The single most critical challenge in adapting a dog-trot home to a northern climate is deciding what to do with the trot, the central open corridor during the winter months. If left permanently open, moving between the kitchen pavilion and the sleeping pavilion becomes an icy, dangerous ordeal. However, if permanently sealed the corridor with solid drywall and standard windows, you destroy the architectural soul of the home, turning it into a conventional boxy ranch house. The modern engineering solution is the installation of a dynamic, operable, transparent envelope, specifically heavy-duty architectural sliding glass walls or industrial folding glass doors. During the late spring, summer, and early autumn, these massive glass panels are rolled back completely into concealed wall pockets, restoring the home to its traditional open-air southern configuration. The wind flows freely, and the breezeway functions as a shaded outdoor patio. When the first winter freeze arrives, the homeowner glides these glass walls shut, transforming the open breezeway into a sealed, weather-tight sunroom or winter garden. To survive extreme sub-zero temperatures without creating a massive thermal drain, standard residential glass is entirely inadequate. Builders must specify three-paned, argon gas-filled structural glazing encased in thermally broken aluminum or timber frames. A thermal break is a non-conductive composite polyamide insulating strip placed between the interior and exterior metal frames, preventing the freezing outdoor temperatures from migrating through the metal into the home. When sealed, this transparent armor stops blizzards in their tracks while maintaining an uninterrupted floor-to-ceiling visual connection to the snow-covered landscape.
While the sealed breezeway acts as a transitional buffer, the two flanking living pavilions must be engineered as ultra-tight, hyper-insulated thermal vaults. In a cold climate, traditional stick frame construction with standard fiberglass cavity insulation is notorious for thermal bridging, where heat escapes rapidly through the wooden studs, and air leakage, which drafts cold air into the living space. To achieve high efficiency or passive house standards in a winter dog-trot, architects overwhelmingly turn to structural insulated panels, commonly known as SIPs. A SIP is a high-performance prefabricated building panel consisting of a dense core of rigid polyurethane or expanded polystyrene foam sandwiched between two structural facings, typically oriented strand board. When the pavilions are erected using SIPs, the walls and roof form a continuous, airtight monolithic blanket with exceptional R values, often exceeding R40 for walls and R60 for roofs, with virtually zero air leakage. To further reinforce this thermal envelope against severe Arctic blasts, builders apply a layer of continuous exterior insulation over the structural framing by wrapping the entire exterior of the pavilion in rigid rockwool or polyisocyanurate insulation boards before attaching the exterior siding. Designers completely eliminate thermal bridging. This approach creates a warm wall assembly that prevents interior moisture from condensing within the wall cavities, ensuring that the living and sleeping quarters remain blissfully warm, draft-free, and highly energy efficient, even when external temperatures plummet 30 degrees below zero.
When adapting a dog-trot to a cold climate, the central breezeway should not merely be a passive space that requires artificial heating. It should be engineered as an active solar collection engine. By utilizing the timeless principles of passive solar design, architects can turn the sealed winter breezeway into a massive free heat generator that warms the entire home. The first rule of passive solar dog-trot design is solar orientation. In the northern hemisphere, the home must be sited so that one of the large glass openings of the breezeway faces directly south, within 15 degrees of true south. During the winter, when the sun travels low along the southern horizon, solar radiation streams through the triple-glazed south wall, flooding the sealed winter breezeway with shortwave infrared energy. To capture and store this free solar energy, the breezeway must incorporate significant thermal mass. Instead of laying lightweight timber decking, the floor of the breezeway, and ideally the adjacent pavilions, should be poured as a thick 4 to 6 inch slab of architectural polished concrete, dark basalt stone, or dense slate tiles. Throughout the freezing sunny day, this dark, dense flooring absorbs the solar radiation like a thermal sponge. As the sun sets and the outdoor air temperature plummets, the thermal mass slowly releases that stored heat back into the breezeway over a period of 8 to 12 hours, dramatically stabilizing the indoor temperature and reducing the demand on mechanical heating systems.
One of the greatest energetic advantages of the winterized Dogtrot is the concept of thermal zoning. In a conventional home, the entire floor plan is typically maintained at a single high temperature, consuming immense amounts of energy to heat unused hallways, entryways, and formal dining rooms. The Dogtrot layout naturally divides a home into 3 distinct controllable thermal zones: Pavilion A, Pavilion B, and the central corridor. During the depth of winter, the 2 living pavilions are maintained at full domestic comfort levels, perhaps 68 to 70 degrees Fahrenheit. The central sealed breezeway, however, can be managed as a semi-conditioned or temperate buffer zone, allowed to float between 50 and 60 degrees, depending on solar gain and outdoor conditions. Because you are not paying to keep this massive central volume at full room temperature 24/7, your overall heating bills drop significantly. Furthermore, this semi-conditioned breezeway functions as a giant whole-house airlock vestibule. In a standard house, opening the front door during a blizzard blasts freezing Arctic air directly into your living room, instantly dropping the temperature and causing drafts. In a winterized Dogtrot, the primary exterior entrance leads into the temperate breezeway. You step inside, stomp the snow off your boots, and close the heavy exterior glass door behind you before opening the secondary interior door leading into the kitchen or bedroom pavilion. This double-door airlock system ensures that the pristine, highly conditioned air inside your living quarters is never exposed directly to the harsh winter elements.
The defining visual feature of any Dogtrot house is its single continuous roofline that spans across both enclosed pavilions and vaults over the central open space. While a wide, low-pitched roof is simple to build in the warm south, adapting this structure to northern snowbelts requires serious, uncompromising structural engineering. Wet, compacted snow can easily weigh over 50 pounds per cubic foot. In heavy snow zones, a continuous roof must be capable of supporting tens of thousands of pounds of static load without sagging or failing. To support this immense weight, particularly across the wide column-free span of the central breezeway, architects must replace standard timber rafters with engineered glue-laminated timber beams or structural steel I-beams. These heavy-duty structural members distribute the roof loads evenly down to the exterior load-bearing walls of the pavilions, preventing any deflection over the open breezeway. The roofing material and pitch must also be carefully calculated for winter dynamics. A standing seam metal roof is universally recommended for cold climate Dogtrots due to its absolute waterproofing and slick surface. However, a slick metal roof presents a fatal hazard: unregulated snow slides. If 3 feet of accumulated snow suddenly breaks loose and avalanches off the roof, it can crush exterior decks, destroy landscaping, or severely injure someone exiting the house. To prevent this, engineers install custom snow guards or retention rails along the lower eaves of the roof. These barriers hold the snow blanket securely on the roof, allowing it to melt slowly and drain safely into heated gutters, while actually utilizing the thick layer of trapped snow as an additional natural layer of rooftop insulation.
In a traditional southern Dogtrot, ventilation is simple. You open the doors and let the wind blow through. But when you build an airtight, super-insulated Dogtrot for a freezing winter climate, you completely eliminate natural infiltration. If you do not provide active mechanical ventilation, the air inside the sealed pavilions will quickly become stagnant, humid, and polluted with carbon dioxide and indoor odors. The mandatory mechanical solution for a winterized Dogtrot is the installation of a heat recovery ventilator or an energy recovery ventilator. An HRV is the lungs of a modern, energy-efficient home. It continuously extracts stale, moisture-laden air from bathrooms and kitchens and exhausts it outside, while simultaneously drawing in a fresh stream of outdoor air. Inside the unit's advanced heat exchange core, the thermal energy from the outgoing warm air is transferred directly to the incoming freezing air, recovering up to 90% of the heat. This means you receive a continuous supply of fresh, oxygen-rich outdoor air, pre-warmed to near-room temperature, without wasting BTUs or opening a single window. For active heating, modern cold-climate Dogtrots abandon inefficient fossil fuel furnaces in favor of hyper-efficient cold-climate air source heat pumps paired with hydronic radiant floor heating. Modern inverter-driven mini-splits can extract ambient heat from outdoor air even when the temperature drops to 20 degrees below zero, providing whisper-quiet, zoned heating to each individual pavilion. When paired with radiant floor tubes embedded beneath the polished concrete or timber floors, the home achieves an unparalleled level of thermal comfort, heating the occupants from the ground up with gentle, radiant warmth. Perhaps the most intimidating technical challenge in designing a split pavilion Dogtrot home for a cold climate is plumbing layout. In a standard house, all plumbing runs through heated interior walls or floor joists. In a Dogtrot, you have two separate physical buildings that both require hot and cold water, drainage, and venting, separated by a central corridor that may experience temperature fluctuations. The golden architectural rule for winter Dogtrot plumbing is wet wall consolidation. Designers must lay out the floor plans so that all plumbing fixtures, sinks, dishwashers, toilets, and showers are located on the internal partition walls within the heated envelope of the pavilions. You must never run water supply lines inside exterior walls or within the floor joists directly above an unconditioned crawl space or an unheated deck. How do you connect the utility infrastructure between Pavilion A and Pavilion B without risking catastrophic pipe freezing? There are two primary engineering methods. The first is deep subterranean trenching. All primary water supply lines, electrical feeds, and hydronic heating loops are routed between the pavilions underground, buried significantly below the local frost line, often 3 to 5 feet deep, inside an insulated waterproof utility conduit. The second method, utilized when subterranean routing is impossible due to bedrock or elevated foundation designs, is the creation of a heavily insulated ceiling chase running through the roof structure above the breezeway. All connecting pipes are bundled inside a rigid, highly insulated duct channel wrapped with self-regulating electric heat trace cables. These smart cables monitor the pipe temperature and automatically pulse low-voltage heat the instant the temperature drops near freezing, guaranteeing that your plumbing remains liquid and functional during the most brutal polar vortexes.
Winter climates are notoriously brutal on exterior building materials. The combination of intense ultraviolet radiation reflected off snowfields, sub-zero temperatures, driving sleet, and continuous freeze-thaw cycles will rapidly destroy conventional wood siding, cheap vinyl, or porous masonry. When moisture penetrates a material and freezes, it expands by 9%, causing cracking, spalling, and structural decay. To ensure multi-generational durability, a winterized Dogtrot must be clad in high-performance, weather-impervious materials. One of the premier choices is Shosugi Bon, or charred timber. By charring the outer surface of wood planking with a high-intensity torch, the cellulose is converted into a hardened, carbonized layer that is completely hydrophobic, meaning it repels water entirely. Because water cannot penetrate the wood fibers, freeze-thaw damage is eliminated, and the dark alligator skin texture provides a stunning, high-contrast visual against a white, snowy landscape. Another exceptional material for cold-climate Dogtrots is Corten weathering steel or heavy-gauge corrugated metal siding. Corten develops a dense, oxidized outer rust layer that seals the underlying steel from oxygen and moisture, creating a permanent, zero-maintenance armor that withstands extreme winds, ice storms, and heavy snow impact without chipping or cracking. For a more refined, modern aesthetic, architects frequently specify high-density fiber cement panels or thermally modified timber, wood that has been baked in a zero-oxygen kiln at extreme temperatures to permanently alter its cellular structure, rendering it entirely immune to moisture absorption, warping, and fungal decay in damp winter environments.